solve one by one. Okay, are the problems visible for everyone? Okay, nobody's answering. Listen, you can just unmute and answer, okay? So please let me know if the problems are not visible for anyone. I'll share my screen and I'll show the problems.
Ma'am, it's not visible.
It should be under live coding problems.
Yeah, Bob, it's visible.
Yes, ma'am, it's visible.
Okay. I'll show you once where to find. Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
See, under this, in this left-hand side panel, under live coding problems, you can scroll down and there's week 3 live coding. Right. So the first problem, let's look at it. So this week we are going to be focusing on linked list and stack and queue. Okay. So first 3 problems are from linked list only, and then there is one problem for stack and queue. This is the first problem. So I'm going to again use Spider. You can use any ID you want, or you can directly write here also. So first problem is saying remove duplicate from sorted linked list. Now everyone is, I hope, clear on what is a linked list, right? Anyone who has a doubt on what is linked list? Okay. Now still I'll just give a brief. A linked list is a data structure, right? It is a data structure where there are multiple nodes and they're not stored contiguously in memory. So every node carries 2 parts. One is the data part, one is the pointer part. So the pointer part of one node will point to the next node. So like this, it is all these nodes are linked together, and the last node in the linked list has its link part or pointer part set to null, because that there is no more nodes after that, right? So that's how you know that you have reached the end of a linked list. So this linked list data structure, now how we are going to implement it, you will see it here. But the actual problem is that how do we remove duplicate from sorted linked list? So first tell me something, if a linked list, okay, let's say any linked list is there, is it possible to perform a binary search on it?
No, ma'am.
Why?
Ma'am, because we actually go from one node to another via pointers. It's not a
Right.
contiguous memory, ma'am.
Right. So since there is no concept of index here, right? No continuous indices like that. So binary search is not applicable. Now, see, this class node that is written in the problem. So this is basically the class which defines a node, right? Inside this class node, we have a definition of a method called init, in which we have this object variable which is self. This self variable just denotes the object of this node class. So init function basically does what, whenever you are going to create a new object or a new node of this node class, then it is going to automatically call itself, right? This init method will be called, and what this method does is it will just create a node, and a node has 2 parts. So self is a node. Think of it as a node. So self.data is the data part in which you can store the data, and self.next is the link part. So for any node, the next self.next part will carry the pointer to the next node, right? And if there is no next node that exists, then it can store null or none in this case. So it is saying that consider an implementation of a linked list where each node is created using the given class node. Okay. So every time we want to create a new node, it is an object of this class node. Suppose it has a head variable that contains the reference to the first node of the linked list. Now, how do I know where is the first node? Head is a variable which contains the pointer to that first node of the linked list. Okay. Head is not the first node. It just contains the address of the first node, or it is just pointing to the first node. Okay. So you are given a non-empty linked list with n nodes, where these nodes are sorted in ascending order of their value. Your task is to remove nodes with duplicate values from the given list. Now write a function called remove duplicates, which will take head as the parameter or argument, where head is a reference to the first node of the sorted linked list. So this function should do what? It should remove all the duplicate values, and it should give, after that, if I print the linked list, it should be just unique values. Now, if a linked list is sorted and contains duplicate values, then one thing is clear, that all the duplicates will club together, right? Like 1 1 will be together. It won't be 1 2 1, because then it's not ascending, strictly ascending or sorted. So 1 1 2 2 3 3 like this. Wherever there are duplicates, they will be together. So now how do I write? How do I approach this? Any ideas?
Ma'am, we have to traverse from head till the last to search that first value, and
Okay.
then after that, we'll just compare it with the next value. And if we want to remove, we'll just change the pointer to the next value, which has to be removed.
Right. So basically, I can have two variables, right? I can take two temporary variables. In the first variable, I can store head, which is pointing to the first node. And then I can, in the next variable, I can store head dot next. So what will head dot next store?
The second
The
node
second
address.
node. Correct. 1 second, someone's trying to enter. Yeah. So in the second variable, we're going to store head dot next, which is the second node. So when I compare these two, right? First, I have to know that okay, let me start writing, then I can explain. You can also start writing with me. Okay, first thing is that we first need to create the linked list. So first, let's
Ma'am,
write. Yeah.
in the portal, do we have to write the class node or we can directly write the
No,
function?
you can direct. You just have to write this remove duplicates. Okay.
Okay.
Since I am writing in Spider, so I'll be explaining all the methods only.
Okay.
If you don't want, I don't need to. So if anybody does, like if you people all agree that you don't need the other methods, then I will skip over that. So you tell me, do I just tell you the remove duplicates, or do I show you the entire how to create linked list, that part?
I think you should show the remove duplicates.
Okay, then just that, right? Then,
Ma'am, please show other methods also.
okay, you don't have to write the other methods, okay, but it won't take much time. Let's just learn it once quickly, and then we can write the remove duplicates. Okay, so just how to create. So first you will write a class for this, right? This all will be given to you. So class node. Now inside this, I have to define the init, right? So init, what parameter will init take?
Self and val and next.
It doesn't need to take the actual data, right? It is just the definition of the function. When you call it, you can put the value of the data, whatever you want. Okay, so here I will just write self, which is the object, and next is data. Currently I will just set it to none. That means if you don't pass a data, then it will just automatically take none as default. Okay.
Ma'am, how would we store that value inside that then if we don't have it?
In this particular problem, you won't be needing it. That's why I'm putting it like this, because this node, this init, will only be called once while creating the head. Okay, so that doesn't need, head doesn't need any this thing, data part. Okay, it is just like the first node that you're creating. I'll explain. 1 second, just let me write, I'll explain the thing. Okay, so first is this self, and then there is data which is set to none. So that means if you don't pass a data value, it will take none as default. Okay, then self dot data. So there are two parts. Self dot data, this is the first part of the object, which is the data part, and then there is self dot next, which is the link part. So that is also set to none initially. Okay, now any node that you create, it will have this basic structure, any node. Okay, because when we are creating the node, it doesn't need to have any data assigned to it or any link assigned to it. This is just the structure of the node. So for any time you create a node, this is the class object of this class node. So this init function will be called automatically. Now next function we'll write is how to append. Okay, that means if I want to add a new node. Okay, so if I want to add some data to my linked list, that means I have to create a new node. But how do I know that like some starting point has to be there? So that starting point is the head node. So define another function. This is outside of the class node. Okay. So def append. So for this I need the head. That means where is the starting point, and data, the data that I want to insert in a new node. Okay. So first thing is what? If this is the first node I'm appending in the linked list, right? Head points to what? The first node. Head is a variable which contains the pointer to the first node. Now if there are no nodes currently in the linked list, then what will be the data part for the first node that I create? None.
Yes.
Right. So if head dot data is equal to none, that means this is the first node. Then you will store your data. So head dot data will be then assigned data, this data that you're passing. Okay. Next, if it is not the first node, that means there are some nodes already in the linked list. Then if you want to append, what do you have to do? You have to travel till the end of the linked list and then append, right? So how do I append at the end? For that I have to traverse. So till
While
when? So till when? What is the condition that I
head dot next is none.
head dot next or temp dot next? Okay, I don't
Yeah,
want
temp
to
dot,
mess with
sorry,
head.
sorry.
So I will store head in a temporary variable. If I use head directly, then the first pointer will be lost, right?
Yes.
So in the else part, I will write some temporary variable I'll take in which I will store head. So that head is also preserved, but I also have the address of the first node in another variable called temp. Now I'll use temp from now on. So while temp is temp dot next is not equal to none. That means the last node only will have the address part or link part as none, right? Other all nodes will have some value pointing to the next node. So until we reach that last node, we have to keep on traversing. So until this condition becomes true, temp will be assigned to
Temp dot next.
temp dot next. That means the next node address. And then once I come out, when will I come out of the loop? When I reach the last node for which the next part is equal to none. So temp dot next, when it becomes equal to none, that is the end of the linked list. So I'll come out of the loop, and in temp dot next, that is the last node's address part, now I will create a new node and store that. So you have to call that, this is a object of which class? Node class. So I will create node with some data value that I'm passing. Okay, this data value will be stored where? In that node's data part, the new node that I'm creating, right? I want to append some data, so that data has to be stored in a new node. So I first reach the end of the linked list, then in the last node's address part, now that address part will point to the new node which is appended after that. Okay, so this is done. Next, I will create one more function for displaying, right? I have to display also. So def display, this will display your entire linked list when we call this. So this, for it to display the entire linked list, you have to give it the head which points to the first node, right? After that it can just traverse and print. So again a temporary variable in which I store head. So temp is assigned head. Next let's print a line. So print output linked list. Will be using this function once the duplicates are removed, and I'm going to print the linked list with all the unique values. So we'll end with a space. Okay. Now we have to traverse through the list. So what is the condition for that? While temp
Is not equal to none.
temp is not equal to none. So till then we will do what? Print every node data. So print temp dot data, and after every print we'll have a space, so end with that. And then how will you move on to the next node? Temp equals to
temp arrow, temp dot next.
temp dot next. In C we use that arrow, right? Okay. So this is the display. Now we will write the statement to take input. Okay, I haven't written the actual function yet, but let me first complete this part. So let's write print, enter linked list, or just all the values you want in the initial linked list. Okay, end again with some space. Now we have to take input. So in a variable, I'll take the input and we are going to split it according to that space, right? Wherever we find a space, there will be a split. So int of I for I in
Input.
input dot split. And we're splitting according to the space. So this is my input. Every item that I'm taking as input, I'm splitting it first and then I'm making it integer type, because first it is a string, right? Then we're making it integer type and it will be in the form of a list. Then we'll create the head node. So in head, we are storing the address of the first node. So basically this is the first node, right, that you're creating. So initially that is empty. It has no data. That's why you don't have to pass any parameter, just write node. So it will take default data as none. After that, what do I need to do? First thing is I need to append all these elements, right? So for I in A, this A list, every element I'll go through and I'll append. Call that append definition function that you wrote, head, comma I. Two things it has to take, the head node and the data part of the node that you want to insert. So the first I is the no, I in A, right? So that is the item. This is in Python. How do we traverse through?
Yeah, sorry, ma'am.
Okay, A of I is in C.
Yes.
Okay. So you will append it. So now your linked list will be created after this for loop is over. Then you'll come out of the loop and you will call this remove duplicates, which I'm going to write now. So there will be this.
Ma'am?
Yeah.
This append is a method. Then we
Yeah,
have
this
to,
is. Go on.
won't we write it like head dot append?
No, you don't have to write. Just calling the append will do. Okay, because this is not returning anything. If you just call the function with the head node and the current data that you want to insert, so it just has to insert that data. It doesn't have to return anything. Just write
Also,
append.
ma'am, append method is, I mean, it's a function. It's not a method. It's not inside that particular class, right? So we
No.
don't need to pass that object dot method name.
Yeah, exactly. So this is something we already defined. Okay. So remove duplicates is the function we have to write. So remove duplicate will take head as its parameter, and lastly we'll display once all the duplicates are removed. So display and give the head pointer. Now let's write remove duplicate. So define remove duplicate, taking head as argument. First we'll have one variable called temp1, in which I will store the address of the first node, which is head. Then temp2. In temp2 I will store the address of the second node, that is head.next. These are the first two nodes that I'll take for comparison. Now while temp is not equal to,
where is the address getting stored? I did not understand. Data I understood. But
see, these are pointers actually. Okay. So head is carrying what? See, head is a variable that points to the first node of the linked list. So whatever information is stored in head, that is now stored in temp1. Okay. In see the
no, not there, ma'am. The init method.
init method.
Actually,
Which part
the
will be?
node contains two parts. One is the data part and another is the next node
Yeah,
address.
one is the link part.
Yes.
So data part will store the data. Okay, and the next part is storing the address of the next node, where the next node is stored. So when you say temp1 equals to head, so you're assigning head to temp1. That means if head is storing the address of the first node of the linked list, then that is now stored in temp1, because we cannot directly use head.
No, ma'am, but I am not seeing like where is the next variable in a node.
Next, this is in init we have defined, right? Whenever you're creating a node object of this class node, then that object will have two parts. One is the data part, one is the next part. So this self thing you're saying, this is the node only.
Understood, ma'am. Now the self dot next for the first element should be the address of the second element, right?
Correct.
Okay. To where, but it is none here in the init. So which step it will become an address actually to the second element?
No, this is just the structure, right? So when you are creating, when you do this append here, right, then you are going where to this append function. So here now see temp is equal to temp dot next. That means every time you're creating a node, you're already storing the link part. So temp dot next is equal to node data. That means whenever you create the new node, right, that node's address is stored in temp dot next. There is the previous node's next part, link part, is carrying the address of the next node. Append is storing where? At the end of the linked list, right? So this while loop.
In C++ pointers, it's very clear, but here I am not getting the idea. Like
Line number
temp dot-
23.
temp dot next.
No,
Understood.
this is
Temp
very
dot next
simple.
is a
Let me tell you one more time. Okay. See. First, we have this while loop which is traversing through the entire linked list. Correct. Until I reach the last node. Last node, how will I identify that temp dot next? So this temp is currently the last node when I reach it, and the dot next. This link part will contain none for the last node. Agree? This much.
understood, ma'am. But I am not understanding the node structure itself. Where is the node structure getting
This
created?
is the node structure, this init. Okay, whenever you are writing this, whenever see in line 23, when I'm actually appending the next node, right? So in temp.next, that is the last node that I currently have. The link part of that is currently none, but now I'm appending one more node after that. So the link part is now updated to that node's address. So temp.next is equal to node data. So here
Node
I am.
data. Node data means data will go and next will become none, right?
No. See, this is the
No, once
structure
you
of the
include
node.
node class,
I understand what you're saying. See, node when I'm calling here, right? This is I'm creating an object of the node class. That is, I'm actually creating a node. Now that node has two parts again, the data part and link part. The data part will contain the data that I'm passing as argument, but the link part of that node is null. But the node is getting created, right? It is getting stored somewhere in memory. That memory location is stored here in temp.next. Okay, this init part does what? The new node that I'm creating, it is the structure of that node.
understood. Ma'am. Now let's say second node is created. So what will be the first node's next?
Then that will be the address of the second node. So then first node's next is now at the temp.next. The temp variable is just traversing again, right? When you append the next.
But ma'am, when we were adding first element, the next of first element was none.
Yes.
Now we are adding the second data. Let's say
Yes.
0, 1,
So the
2.
next of first element is now the second element address.
Next has been none always, na ma'am. I'm not getting where the
None when you are creating the node. When you are creating the node, then the default value for the next is none. But when you create another node after that, then you have an address to point to, right? Before that, you don't have an address to point to. If that is the last node, then obviously the next has to be none. But after I add the second element, after the first element, now the next of the first element has an address to point to. Now it can point to the second node. So that update is happening in line 23.
ma'am, in line 23, node of data is being called, right? Object is being created.
Created, yes. And that address is being stored in this link part.
No, where is the address? The node of data.
This itself will do that assignment. Whenever you call that, whenever you create that object, automatically that address is being stored here because this is a pointer type variable. Okay, it will store address. Every time you are creating it, this will be the structure and the address will be stored here only. This temp.next is equal to node data. Whenever you are creating, that same address is immediately getting stored in temp.next.
It's same as saying temp arrow next is equal to malloc
Yeah,
of
that
node.
memory allocation that we do in
Yes.
C, right? So
So
here
the
we don't have
address
to
is
write all that. Okay. Okay, you tell me
You
which
can
part
go ahead,
is
ma'am.
too.
I am not able to digest. Like if you draw the boxes, no data
Yeah, yeah,
and
I'll draw it. I'll draw it. I'll show you.
uh,
Wait.
so I am understanding object being created, but
Hmm.
not understanding next is going to contain actually what. That I'm not
Next
understanding.
is going to contain the address of the next node. See, here in the problem statement, it is given that head stores what? Head is a variable that contains reference to the next node of the list, first node of the linked list, right? Head contains reference to first node of the linked list. Similarly, first node contains reference to second node of the linked list. This reference is stored where? In first node's next part, dot next. Okay, so this reference is nothing but the address only. Wait, let me just write it once, I guess.
Ma'am, in the class, dot next is just an variable of that class, of that object, right? Any object that is created, node object.
Yes, so there are two parts of that. One is the
It's
data
like,
part, one is the link part. That is the dot next is the link part, right?
correct, but in dot next, every time we are again invoking node and in the bracket data. So again, it's going to create blank node only. So this dot next,
So this blank node that you're creating, where is that node getting stored? Immediately that address is being stored in temp.next. Wait, let me
okay,
just
for
write.
we'll understand that yeah, the address is there. But temp dot next is getting updated now, ma'am. So where is our linked list finally?
I'll show you, I'll show you. Just give me a second. I'm just trying to find a blank PDF. Okay, here only let me write. This thing isn't working. Okay. Can you see anything I'm writing? This.
Yes, ma'am.
Okay. Look. Head is there, right? Head is storing what? Reference to the
Refers
first
to the
node.
first node.
Okay. So let's say now I want to append this 10 value as my first node, right? Currently, just head is there. Okay. So what is the, let me open the code. This is the thing, right? So head is pointing to first node. So now when I want to append this first node, the data in the first node, okay, head just has an address. If I want to append the data, so I have to go to this definition, right? So if head dot data is none, that means that whatever address head is now pointing to, does that have any data stored in it?
sorry to interrupt. When you create the object, you are creating two variables, ma'am, right? Data and
Yeah,
next.
data and next.
For time being, let's forget the variable called address. There is no address.
Okay.
Now, data is data. Whenever it is passed, it is getting created and this thing. But next is always none. So I'm not able to understand when a new
Yeah,
object is
I'm
created.
telling you, I'm telling you. See,
So,
here in this line, when head is getting created, I'm not passing any data, right? I'm just creating an object of node type.
yes,
Okay. So data
ma'am.
part is nothing. Okay, data is none. It will take the default value. So now I want to insert the first value of my linked list, which is 10. Okay. So I will go to append. I will pass the head and the data that I want to pass, that is 10. So head dot data is none. Is this true right now? Head contains data which is basically none. No data is there. So when this is true, head dot data is none. That means there is no data in the linked list currently. Then I will set head dot data is equal to the current data. So head is what? Head is just a reference to the first node, right? So the first node that I created is now containing 10, but the link part is still nothing. It doesn't have anything. Link is still none. Okay.
Correct.
Head is a variable pointing to the first node where there is data but there is no link. Now you again come to this for loop. Now for the next I, let's say the next I is 20. I want to next insert 20 in my linked list. So again go to append. Now is if head is pointing to the first node, is the data part none? No, data is there. So I'll go to else part. In temporary variable, I will store head. So some temporary variable is now also pointing to the first node. Okay. Now while temp.next is not none. So while this temporary variable, now I'll use this temp to traverse through the linked list. Currently only one node is there, right? But temp.next is not none. Is it true?
False in this case.
It's false because temp is pointing to this node. So temp.next means the next part of this node, which is none. So this while loop condition is not satisfied. So I will come out of the while loop to line 13. What will I do? Temp.next. That means this link part will now be assigned with a new node address, which I am creating now, which is this node data. So in temp.next, which is this pointer part, it is now being assigned to the new node that I am creating, which will store what? 20, because I'm passing 20 as the data here. And the address of this is being stored where? In temp.next here. So the second node is now created having 20 as data, but the link part is none. And now this node, let's take some arbitrary memory addresses. Maybe this is memory address 1000, this is memory address 2000. So this is now pointing to memory address 2000. That is the second node. Okay, again when I enter a third node, let's say memory address 3000 in the exact same way. That contains 30. Link part none. So now this previous node's link part will again be updated to which address? 3000. This is how we form the link. So every time you're creating a new node, that node's address is being stored where? In temp.next. Okay, is it a bit clear?
Yes, ma'am. So basically, we're treating address as an abstract thing.
Yeah, this is an abstract thing.
Yeah. So
Okay.
physically,
I cannot pinpoint it. Yeah.
So there is not going to be an array of all the nexts or all the datas and anything. It is just that one object referring to the other. It's going on, right?
Yes, just a reference. That's why we are not using the term address. Okay, we are just saying that it is referring to the next node. Okay.
Okay. So
But
randomly,
yeah, whenever
I cannot go to any data, then I'll have to go from head
anyways, you cannot traverse randomly in a linked list. That's the first thing about linked list. That in linked list only linear traversal is possible. That's why we cannot do this binary searching. Also, you cannot go to the middle index like that. Okay, only linear search you can do. So random access is not possible in linked list. That is one thing. Because there are no indices.
Understood. Now this temp.next literals are the same. So is the object not getting overwritten? Like when we want to display, let's say, I understood the creation. Let's say creation, some abstract thing is storing the temp.next. But in the display, now how does that guy know that temp is that temp? Or
Because
again,
no, in display we are passing what? The head. Head is only pointing to the first node. From first to end, head is pointing to the first node. Right. So then in display, you're creating another temporary variable inside this method, this function. So there the temp is storing the head. And using that, I'm just traversing the linked list and printing every data.
Understood. So anything we want to do with linked list, every time we'll create something
create
like
a temporary variable, because see, if I directly use head, then I will lose the first node address. That is not stored anywhere else. Right? Only head has that reference. Now, if you have a circular linked list, in that case, the last node will again point to the first node, but this is a singly linked list. So in that case, head cannot be changed. So we just restored head in temporary variables.
Understood, ma'am. So in one sentence, I can say that I have only the head as the reference. Do
Yes.
everything with the head now, and
Yes.
assume that you are
So
traversing objects.
until you create the first node, head is all you have, right? Then the first node has the address to the second node, second has the address to third node. But whenever you want to do anything with the linked list, if you want to find any value within the linked list, you have to start with head. Okay.
Got it, ma'am. Thank you.
Yeah. Okay. So let's
So,
come.
ma'am, at the end, only the last node will have none as the.
Yes. Whenever, like, once you're done, completed, your linked list is created. Only the last node next part or link part is containing none, because there is no node after that to point to. All other nodes have the link part filled.
So the last node has no address at all.
No, last node data part is there, but address part is none.
Okay.
Okay. Now let's write the actual function, that is remove, how to remove the duplicates. So remove duplicates. This method will work because this linked list is sorted. Okay. So again pass head, because that is the beginning. Now in a variable called temp1, we will store the head. And then another variable temp2 will store head dot next. That is the head is pointing to first node, head dot next is pointing to second node. Now your linked list is created, right? So all the nodes are there. Now you will start a while loop. So while temp2 is not equal to none. Why this condition? Because temp2 will be always pointing to the next node. At a time we are just comparing two nodes, right? So the first node, then the second node, then second node, third node, fourth node, like this. So temp2 is always having the second node's address that you are comparing. So that will be what? When temp2 reaches the last node of the linked list.
Temp1
Right.
is equal to temp2.
So after this, we cannot compare anymore. So that's why once it becomes none, then we will come out of the while loop. But as long as it is not none, that means there is some node present in head.next or the current node.next. Then we will do this loop. Now inside the loop, I have to do the comparison. If temp1 dot data is equal to temp2 dot data, that means we have found a duplicate. In that case, in temp2, so what I have to do, I have to remove the duplicate. So since I have found a duplicate, I'll just bypass it. That means, let's say in the second node, I have found a duplicate with the third node. So first node pointing to second node, and second node and third node are containing duplicate data. So now instead of what I will do, instead of first node pointing to second node, right? Now second node, instead of pointing to the third node, will now point to the fourth node. The third node I will just delete or drop it from the linked list. So if there is no node pointing to a certain node, then that is not part of the linked list. Right? So we have to break that link part. So how we'll do that? Once we find a match like this, duplicate value. So then temp2, you can assign temp2 dot next. See, first let me give a little example of how this is working. What else? Okay. Let's say this is the first node, second node, third node, fourth node. These two are duplicates, correct? First node is pointing to second node is pointing to third node is pointing to fourth node. So during my comparison, I will find a match between this and this. So how will I break the link? Now instead of this second node pointing to this link I will break. Second node will now directly point to the fourth node. Okay. So in that case, this becomes what? Detached from the linked list, this duplicate node. That's how the duplicates will be removed. Okay, now exactly this logic only we have to write. So what is the logic? Temp2 will now store temp2 dot next, right? That is the next node. And temp1 dot next is storing what? If
Head temp2 dot next.
just temp2, right?
Okay, yeah.
Think of it like this. See, temp1 is storing the address to the first node.
Temp2 is just dummy.
No, temp2 is the second node initially. Let me just say it like this. Temp1 has the head address, right? Head is storing address to the first node. So basically temp1 is pointing to first node. Whatever I do with temp1, that refers to the first node. Temp2 is storing head.next. That means the second node. So whatever I do with temp2 is the second node, right? So when I'm comparing temp1.data is equal to temp2.data, that means data part of the first and second nodes. If they match, then temp2 is now storing what? Temp2 was initially storing address of second node, right? So temp2.next is what? Address of third node. So now that third node's address is stored in temp2. And temp1.next. So temp1 was initially storing what? Address of first node. So what is that? Head.next, if you think. What is that?
Address of the
Ma'am, can you
second node.
repeat once?
Temp1 was initially storing head. Head is
Yes.
the address of the first node, right?
Yes.
So that dot next means what?
Address of
The
the second
link part. The link part of the first node, right? That I'm referring to. Temp1 dot next.
Correct.
So that is now storing what?
The address of
temp2.
the next
Temp2 node.
Just temp2.
Yes.
Should I write
Okay,
this and
okay.
explain?
No.
Ma'am,
Yeah.
what is head dot next?
See, head is what? Referring to the first node. So head dot next means first node's next part, which is storing address of second node.
Address of the second node.
Yes. Head is first node. So first node dot next, head dot next, same thing, which is the address of the second node. Next part is always storing address of next node, right?
And temp1 is the address of the first node.
Yes, temp1 is address of first node, temp2 is address of second node. When they match, then I have to remove the duplicate. So which one am I removing?
The second one. Temp2.
Actually, in this, first of all, if there are only two nodes, okay, if there are only two nodes, then this temp2 is not none. Is this working? Let me give an example.
No, ma'am. It will become none, ma'am, because after the temp2 next will be none.
Yes,
Temp2
ma'am.
dot next is none, right? Temp2
Yes.
exists. Temp2 dot next will be none.
Yes.
Okay, that's
Temp2
okay.
dot next.
So
Yes, ma'am.
yes. So if these are the first and second elements, then I have to remove the duplicate. So that's why temp2 is currently storing what? Temp2 dot next. That is pointing to the third element now. And
Yeah.
temp1
Yes,
dot
ma'am.
next is that second element again. Basically,
Okay.
Ma'am, can
second
you
element
write
is gone.
this?
Yeah, I'll
It's
write.
getting.
Ma'am,
Linked list is a little
we
confusing.
could have directly
Ma'am.
done temp1 dot next is equal to temp2 dot next. Na? Why didn't we do that?
Temp1 dot next is equal to temp2 dot next, you're saying.
In the not here.
Why will I do temp2 dot next? Wait.
That's what we are doing now, ma'am. Finally, not here. Where your spider you are writing now.
This one. Yeah. Which one you want to change?
Line 11 was not required. As such, temp2 we want to bypass, right?
Temp2
So
we
what?
want to, yeah.
Ah.
So you want what line? You tell me the exact line you want. Temp1 dot next should store what?
temp2 dot next. The line 11 was not required.
But then we will lose temp2, na? Which is required for the while.
No. Why temp2 dot next we will assign to temp1
Wait.
dot next.
Let me write it in an example, then I'll explain to you. Okay. Let's say this is my first node. Okay, and the second node is also 1. Okay. So temp1 was initially storing head, which is basically pointing to this node, correct? This is
Yes.
temp1.
Yes.
Temp2 is storing what? Head
The
dot
second.
next,
Next. Yes.
which means this node,
Yes.
this one. Okay. Now let's say this is stored at some 1000 memory location, this is some 2000 memory location. Okay. So now we have found a duplicate, right? What is the condition? That temp2 should not be none. Temp2 is not none, temp2 exists, right? Head dot next has a valid address which is 2000. So while condition is satisfied, now come inside the while loop, you compare temp1 and temp2 data parts. So temp1 data part is what? 1. Temp2 data part is also 1. Okay, it's a match. So next line was, if you find such a match, you do temp2 is equal to temp2 dot next. So what is this temp2 dot next? Let's say I have one more node after this in my linked list, which is storing 2. Okay, at some other memory location 3000. So temp2 dot next is basically this pointing to this node, right? This pointer. This is temp2 dot next. Is this okay or not? Up to this.
Yes, ma'am.
Correct, ma'am.
Okay.
Yes,
Then I
ma'am.
said that it is next line is temp1 dot next is now storing temp2. So what is temp2 right now? This third node. See,
Yes.
temp2 is storing temp2 dot next.
Yes.
This is the third node address. And this third node address is now being stored where? Temp1 dot next. That means this node now stores 3000. And this node is now completely gone. It is not required.
Ma'am, I am saying this could have been accomplished by writing temp1 dot next is equal to temp2 dot next now.
Okay.
Temp2,
Temp1
just
dot
the temp2 way.
is temp2
I mean,
dot next.
instead of 2 lines, with 1 line we could have done that.
Let me see if
But
anything
we
is
are
getting
losing
lost.
temp2, no?
No, temp2, since that variable is not required, that's why he's saying. Since that
Ma'am,
variable is
in
getting
while we require na while loop.
in while loop. See, now that you're updating, right? After that, you are all updating this temp2, right? Temp2 dot next. Now, when you go for the next while iteration, this is the temp2 that you are comparing. That is it none. So you cannot lose this temp2, right? That's why we are having 2 lines. In the while loop, the condition is what? See, here the condition is every iteration I am checking whether the temp2 exists or not. Right? Temp2 address is there or not? Is it none? So if you don't have that, if temp2 is not storing the address, like here, temp2 dot next, then what will you compare with? That's why we have both variables, temp1 and temp2. Temp1 is to what? Bypass that link of the node that we don't need, which is the duplicate node. Temp2 is for the next iteration, so that you know that okay, there is a next node that with which I can compare. Right, after this, see, if there is no node, okay, after this 3000, let's say there is no node, then temp2 will become none in that case, so you can step out of the while loop. Otherwise, what will be the condition to get out of the loop? Is it clear?
Understood, ma'am. So it is basically not, it is serving the purpose of that condition,
Loop iterator.
not as a dummy to store
Yeah.
this thing. Okay.
No, it's not a dummy, it is for that loop iterator. Okay.
Ma'am,
And
I think he himself had given a solution for that. What he said was he can make after that temp1 dot next is equal to temp2 dot next. He would write temp2 is equal to temp1 dot next. I think that will work, ma'am.
see, temp1 dot next is storing what?
Temp2 dot next, and then
This.
what he says is temp2 is equal to temp1 dot next. This is basically the same thing which what we are doing right now.
Yes,
That
yes, yes.
the temp2 will
Temp1,
start pointing the
yes,
last
yes.
node.
If you do that, yeah, that will work. If you write that extra line, then you can use it.
Yes, ma'am.
Okay. So this is how you can bypass that duplicate node, right? And next, what is the else part? Now, if I don't find a match, then I have to update both the variables temp1 and temp2 to move on to the next, right? So else part will contain else if there is no duplicate, then temp1 will store what? Temp2, simply. Just passing the, just traversing along, right? I did the first and second, now I'm doing second, third. So temp1 storing temp2, what will temp2 store?
Temp2 dot
Temp2 dot
next.
next.
Temp2 dot next. So this is how we can remove duplicate, right? Every duplicate that I have, I'm just bypassing that node, right? I'm just breaking that link by doing these 2 lines here. And if you don't have any duplicates, then you just go on to the next node. That's it. So let's run this once, then I'll take any query you have. Okay, somewhere I missed that. Which line is it showing? While temp not none. Okay.
16 line number 16.
No, 16 it's not. Oh, okay, this. Why is it written twice? Did I write it twice?
Okay, yes, ma'am, I think.
Okay.
Yes, ma'am.
Okay, now let's enter the linked list. Let's say I want to enter 10, 20, 30, 40, 50, 50, 60. Okay. Remove duplicates. Yes. Okay, let's take 1, 1, 2, 3, 4, 4, 5. So it is all unique elements, right? So it's working. Now you tell me which part of this code you have a doubt in. Any part.
Ma'am, we can use a single TMP.
Single temp.
Yes, ma'am.
Which part? Where? I mean, in the remove duplicates.
Yeah.
Okay, how do you propose that?
Can I show you the code?
You can post it in chat. Okay, I'll check.
Okay.
Definitely. See, this can also be done in different ways. If your code is working, if you're getting the output linked list without any duplicates, then it's definitely fine. Your logic is okay. Just test it and you can send it to me. I'll check.
Ma'am?
Yeah.
I didn't understand the remove duplicates part. If you are assigning temp2 is equal to temp2 dot next, no, then
temp2 is equal to
temp2
temp2 dot
will
next, right? So temp2 was initially pointing to second node. So temp2 dot next is address of third node, right?
yeah, then
So now after assigning temp2 to temp2 dot next line what I'm doing, temp1 dot next is now assigned temp2. That means temp1 dot next is now pointing to third node, not the second node anymore. Because temp2 itself is storing what? The third node address. Right. So that third node address is then being stored in temp1 dot next part. So that the second node is bypassed because that's the duplicate node. Okay. I'll come back to this. Okay.
Ma'am, I've posted the code.
Okay, I'll check. Yeah, tell me. Any more doubt here?
Ma'am, in short, I would like to admit this C++ we used to do star P++, no? That was easy to understand.
See, in Python we don't have that, na. That's why the notation gets kind of confusing. In C also we use that star notation for pointers. That is
That
not
was very
here. That's
easy
why
because
it
star
is.
P++ means you know that you are incremented address directly.
Yeah, but like in your DA paper also, this is PDSA will be implemented in Python only, right? So you have to get acquainted with this.
Yes. So with object, it was a little abstract notion. You have to imagine that
Yes,
next
because
actually.
see, when we in C also we did that malloc, right? So we know that exactly memory is being allocated here, and that's the address I'm storing. But here there is no such thing. Wherever you're creating the node object, that is the address you have to assume. Okay.
Yes, ma'am.
See, this logic I will once again tell for the people who didn't understand. First, temp1 is storing the address of first node. Temp2 is storing address of second node. Head is storing address of first node, so that is in temp1. Head.next is obviously address of second node, that is in temp2. Now, how long will the while loop run? Until we reach what? Temp2 is not
last
equal to
node.
none. So until then, I have to do all the comparisons, right? Until I reach the last node. I have to do every comparison. So that's why this condition temp2 is not equal to none. As long as this is true, we'll keep on comparing. What we are comparing is temp1 dot data part equal to temp2 dot data part. That is first node and second node. Are they equal? The data part. If equal, that means they are duplicates. So what I'll do, I'll delete the second node. So that the first node directly points to the third node. That's why the duplicate is now being removed. How you'll remove that duplicate? In temp2, the variable which was previously pointing to second node. Now I will store the address of the third node there. That is temp2.next. And this third node address, now it is safely in temp2. So temp2 is now being assigned to temp1.next, that is first node address part. So first node will directly point to third node. Second node is gone. If there isn't a match, if there are no duplicates between temp1 and temp2 are both unique, in that case, temp1 will now shift to temp2, just one place to the right. And temp2 will shift to temp3, that is temp2.next. And then again do the comparison. Okay. Just do a dry run of this, you will understand better. Okay, should I go to the next question?
Ma'am, what is temp1 data and temp2 data?
Initially, temp1 is pointing to first node, right? So temp1.data is whatever data is stored in first node. Temp2 is pointing to head.next, that is second node. So temp2.data is whatever data is stored in second node.
Okay,
Okay.
so okay. So from someone has said that we can do this in one step only, like
Not
temp.
one step. There also you have to write two set statements only, because you cannot totally bypass temp2. Temp2 is required for this while loop iterator. Okay. So anyways, you
Ma'am,
have to
what
store
is
in
that
temp2.
step?
See, I am not doing that because this is the solution that we are giving, right?
Okay, okay.
So if you can understand that logic, so I think he has shared the code. Can you please just share your code, whoever gave that logic? Then you
Ma'am,
can.
it is shared.
Okay, just look at his code. If you don't understand, then you ask me, I'll tell you. Okay. This is the solution we are following. Just do whichever one looks easy to you.
Ma'am,
Okay, ma'am.
uh,
Yeah.
it is like next is a object variable, but it's itself is a object. If you really
Next is the reference of the next object.
not
Okay. It is
reference,
just the
ma'am,
reference. It
so
is,
it will
see,
have
like
open
in
data.
an object, we can have instance variables, right? It is like that. So temp is the object. It has two instances. Like one instance variable of that is this data part. One is the next part. Next is not an object. Yeah, next is pointing to an object. Okay, next is referring to an object.
No,
So,
next
ma'am,
is an object, na, ma'am. This object next is actually a next object, because we are assigning a node in bracket data to a something dot next. So
Hmm.
it's again an object with its own data and next.
But which class will that belong to? See, a node is an object of the node class, right? And that node has two parts, which is next and data part. So next is pointing to the next object. It is the reference. It is not the object itself, right? It is just reference. That is this memory location. Maybe it is storing that memory location. It is storing, not the entire object. From
No,
next, can you get the data?
I think next is an object. If you type of so and so
Oh,
dot
okay.
next,
You are saying that if
uh,
the object type of next is if the type of next is an object,
yes, ma'am. Because see,
okay, we can just print that and see.
it is kind of nested objects going on, ma'am.
Yeah, you can think of it like nested, okay, because I mean temp2 has now is again pointing to the next node. So that next node is stored in the next part of temp2. Let's say temp3 or whatever is the next node, the third node. That's what you're saying. The link itself you're saying is an
Ma'am,
object.
basically is getting confused with the data structures which are used in C and C++, wherein an object can contain another object. But in over here, we just point to
Yeah,
another
that's what
object.
I'm
We
saying.
cannot
That it
contain
is
it.
just a reference. It is not an
Yes.
object. Okay. Object is the node itself. The node is an object of this class node. Now this self is that object in this definition, right? That self is now what? It is the temp or head, whatever you are doing. That is
Correct, correct,
here.
ma'am. Now you come to the append ka some line.
Hmm.
Uh, Here, once you want to append the next element, you are creating temp dot next is equal to node of data, right?
Right.
So node of data is
Is an
itself is
object. Yes.
being assigned being assigned to temp dot next, whereas next is the variable or attribute of the previous object. So it is the object of object kind of a thing.
In
I cannot.
Python, when you say node data,
Type
basically you are calling the constructor, and the
Yeah,
constructor returns the
the init is
reference
the
to that
constructor,
address,
right?
which you are storing in next
no, no,
variable.
understood. See, just simple statement. Node of data is an instance of node class, means it's an object, separate
Correct.
object in itself.
Yeah.
So, ma'am, temp.next now is not just a variable, simple variable like int and anything. Temp.next itself is an object of node class.
The self is an object of node class. Next is just the a variable which stores the reference to the next node of that class only.
That is the reference variable.
It is a reference variable. Just like data is storing the data part. Next we cannot
But
call next as an object, right? Then I would say node next. It is not a node. It is just
no,
storing the
it's a node.
reference to that node.
It is a node, ma'am. If you type type of next now, it will show node only.
Okay, let's check it once.
Yes, ma'am, that
Because
is true because the reference variable has a type. That
It
next
definitely
will
has a
be to
type.
yeah, it
See,
is
it
of
is
type
storing
node.
that node, right?
Yes,
But it is not a node. It is a
yes,
reference.
yes. It just points to that object which is created in
Same
memory.
like in C, C++, you have a pointer, right? A pointer is pointing to the
no, ma'am,
next node, but
I
we
have
cannot say the pointer is the node.
now pointer is not the node, ma'am. But now here, purely class and object concept, if we see, every next is an object, and that object next is another object.
If you want to see, if you want to think like that, it's fine. But we will always refer to next part as a reference. Okay, we will not refer to this as an object. The object here is just the node. Otherwise, it will be very
Every
confusing. I mean, if then you will say that every
correct,
object is
correct.
containing another object.
Reference is not a data type, no, ma'am.
No, it is
If I
not a data
simply
type.
ask you,
If you are
correct,
talking
let's say,
solely about the type, okay, then next will be of type that object only because it is storing the object, but it is storing just the reference to that object in this problem. Okay, solely if you say type, that is what you're saying, that next type will be an object of this node class.
yes, ma'am, that's what I'm saying.
Yes, we can say that because since in next we are storing another node's reference, and with that next only we are referring to that other node, right? Otherwise there is no other way to reach that node. But we won't call it that here, and we won't call it an object. The node itself is an object. Okay, so we will just refer to it as a reference variable. Or you can think of it as an object if that is what helps you relate to that other language, right? C++, C, wherever we have done it. Definitely in Python, these things are a little different because we are not using any proper pointer symbols or anything. It's just all variables. So which one is address, which one is not an address, reference, these things are a little confusing.
I, no, no, I have delinked from C++. The moment star p I have removed, understood. Now, my only point was every variable has a data type, no?
Definitely. So there will be a type of this also, right?
So if you type now, if you print the type of temp.next, it's going to be
Okay.
a object of node class.
Here
No,
I
it is
don't.
of type node. It is not object of node.
It is not
Object
an
is a
object.
different
Yeah, that's
connotation
what
in
I'm
it.
saying. Object is the entire thing, right? It is of type that, yeah, it belongs to that node class only. It is a reference variable of that node class, but it is not an object of the class. If for it to be an object, it has to be a
It's not a
data
variable.
and next.
No, if it is a variable, then what is it, ma'am? Is it integer or float?
No,
It
it
is
is a
storing a
reference
reference.
variable of type node. That is what ma'am is trying to say.
See, we can't.
Do you
That's
have
what I'm saying.
point? Let's say in case of pointers, when you say a pointer of in type integer, what do you exactly mean?
No. Don't go to pointers. See, okay, I paired with that was for one reason. But I
Okay,
am saying
let
temp
me
dot
just
every
say
time.
one thing. Since this, okay, is the problem clear now? This is the only problem, that what is next, right? Okay, I'll
Yes,
come
ma'am.
back to this. Let me just finish the other problems, then we'll discuss this again. Okay. Otherwise, others
Okay,
are also
okay, ma'am.
waiting.
Sure, ma'am.
Okay.
Ma'am,
Yeah.
in the remove duplication, if we find temp1 and temp2 equal, what do you, we are removing the
temp
temp
2.
2,
Yes.
we are removing the temp 2, and
Temp 1 is pointing to
then
the
after
object that temp 2 was pointing to. That is, if temp 2 was second node pointing to third node, now temp 1, that is first node, will point to third node, and second node is gone because that was the duplicate.
so the temp 2 is moved to the next
Yes,
next
now
node,
temp
and
2 is basically
temp,
the third node, address of third node.
then the temp 1 is
Temp 1 is
moving
first
to
node only, and
the
first node address
temp 2.
part is now pointing to third node instead of second node.
So ultimately, this temp 1 and temp 2 will have point to the same node, no? If the temp 1 and temp 2 are
No, they're
equal.
not pointing to the same node. Temp 2 is now the third node. Okay, so third node will point to fourth node, and temp 1 is still the first node. First node pointing to third node. Second node is the duplicate one, so that is deleted. Okay.
Temp 1 dot next. So temp 1 is not updated.
No. Why will you see temp 1 dot next? Only the next part is updated, right? Next part is now pointing to where? Temp 2. Temp 2 is containing what? Temp 2 dot next. That is third node address.
Oh, okay. So the data is not only the address
Yeah,
it is
only the
updated.
address part. That's why dot next. Data is not
Okay.
updated.
Okay.
Yeah. Okay, I don't know how I will complete.
Hello,
Let's start.
ma'am.
Yeah.
Ma'am, can you show that code again once? Ma'am, to understand it clearly, like in the node part, class node, we are creating the data, like initializing it, and the append part, we are incrementing the part. What is happening in the display part?
The class node is basically just showing you the structure of every node. Okay, every object of this class is a node which has two parts, data and next, which is shown here in the init. Okay, append is doing what? When you want to add a new node. So if you want to add a new node in a linked list, it will add at the end of that list. Display
Yes.
is when you want to print the updated. So once I've removed the duplicates, then I call this display function, right, with the head as parameter. So it will start from the head and then it will traverse through the entire linked list and print every value. So see, in temporary variable, I'm first storing head, that is temporary variable is now pointing to the first node, right? And until we reach a node whose address part is none, that means the next node doesn't exist. That is the last node. Till then, we will keep on traversing. So temp will be updated to temp.next after every iteration. So display is just to traverse through the node, entire linked list and print all the values.
Okay, so display will run at the last.
At the last, yeah. After the duplicates are removed, then I call display.
So first, the node part will be
First linked
displayed.
list is created, then remove duplicates, then you display the unique linked list having all unique characters.
What happened with the append part in
Append
this?
is where you created the linked list, no? So first you took input list of integers that you want in your linked list, and then each
Okay.
integer you picked and appended into the linked list. So there you are calling this append in the for loop.
Okay.
Okay.
Okay, ma'am. Got it. Thank you.
All right, let's do the next problem. So this one is saying, yeah. So now we are dealing with a doubly linked list, right? That means a doubly linked list, what happens? Every node has two pointers now. You in previous one we just had self.next. That means only one link which is going to the next node. Now we have to point to the next node as well as the previous node. Okay. So if I go to the second node will have a pointer which is previous, which points to the first node, and the next pointer will point to the third node. So previous, next, both it will point. Doubly linked lists are used when we want to traverse a linked list in both ways. I can traverse from front to back or back to front. Okay. Or even if you want to let's say insert an element in a particular index or particular node. Let's say first node is node 1, then node 2, node 3. I want to insert in position 3, right? Then I have to change the pointers accordingly. So whatever node was present at position 3 will now become node at position 4. Okay, and a new node will be there in position 3. So all the pointers have to be updated. This is a very simple program. So we are implementing a doubly linked list first. It is asking that for the given class doubly linked list, we have to create a method called insert at pos. So this pos is a position. Okay, that is the position at which you want to insert a new node. And you also have to give the data, that what data you want in that node. So two arguments for this function. One is data, one is position. So it will accept an integer data, which is the data you want to insert in the new node, and insert it into the list at given position. But the position must lie between first and last, right? It cannot be the first node, because then head is not pointing to that. Head is always pointing to the first node. So it has to be greater than, position has to be greater than the first node and less than equal to the last node. That means you can insert at last also. Okay. So that's the range. Now this is the class node is now updated. So it will contain 3 things. Yeah.
So this insert will insert to the left side of the position or right side?
It will insert at the exact position that you're mentioning. If I say position 5, so insert at 5th position. Whatever value in the node or whatever node is present currently at 5th position will now shift to 6th position. Okay, a new node has come to the 5th position.
Okay, the value at the node at 5, position 5 will shift to
Yeah.
6.
So it is
Ma'am,
saying,
if the list does not have that length, ma'am, then
which length?
let's say
If it
5.
doesn't have the position that you're
Yes,
giving,
yes,
When
ma'am.
we
yeah, then
said
it
na,
will
it
be
is having
invalid, right? It is a range. The range is given.
Okay.
Okay. And if you give out of that range, you will have to write an invalid function for that. So the class node will, if every node structure will be what? If self is the object, the self is the node, then it will have a data part. It will have a next part which points to the next node. It will have a previous link part which points to the previous node. Okay, see, these contain the reference of the next node, reference of the previous node. Now you have one more class which is doubly linked list. So this is where we'll create the doubly linked list. So definition is what? Self. See, two things we need. One pointer which points to the first node of the entire linked list, one pointer which points to the last node of the linked list. Okay, so self.head is the first pointer which points to the first node. Self.last is the pointer which points to the last node. So initially both are none. Okay. So now it will be like this. So if this is the sample input 13579, right? 1 is position 1, 3 is position 2, 5 is position 3, like this. Now I want to enter the data 20 in position 2. Okay. So when I give the output, then after 1, 20 should come, then 3, then 5, 7, 9. Okay. So if I print from the front, since it is doubly linked list, I can print from first to last or last to first. So I print from first to last, it is 1, 23, 5, 7, 9, and the reverse. So all these things we have to do. We have to write a function for this insertion at a given position. And I think all the other functions are already given. So I'm not going, I think I don't have time to write the whole thing. So maybe I should just write here, right? So class node is given, doubly linked list, this part is written that init is given and insert end. That means you have to insert at end also. For that, what will be the method, that is also given. So I'm not going into that. I'll just do whatever is asked. That is this insert at position, since we don't have the time. Okay. See, insert end, you can just understand clearly. So it is taking the node object, that is self, and then the data, right, that you want to insert. So you first create a new node for that new data, and then you change all the pointers. So new node, previous, and then head, last, everything you have to change. I can write the whole thing if you want, but then it will take time. Okay, if you want to stay that long, then I can write the whole thing. What should I do? Tell me.
First do insert at map. Let's see if time permits. We'll.
Okay. Okay. So let's start with definition of insert at position. Okay, insert at position. Now what we have to give? We have to give the object reference data, and we have to give the position. Okay, that means this data I want to insert at this particular position. Now the definition. So first, any node, wherever we want to insert it at any position, we have to create a new node, right?
Ma'am, just one thing, ma'am.
Mhm.
Ma'am, this definition signature has been given, or you have
No, it is
decided?
given. It is given.
Oh, okay.
Okay. These parts will be given. You just have to write the function that they're asking.
Okay, ma'am.
Okay. And here I think we have to write that traversal also. Is that given? No. The traversal I think we have to write. Let's see. Okay. So first we have to create a new node. So new node. What will I call? To create new node?
Node.
Node,
Node.
right? It is an object of node class. And
Okay,
what
ma'am.
will I pass? Data.
Data.
The new node is created. Now we will have one variable which is C. I'm assigning it 1. Okay, we'll see why. So this C will be nothing but an iterator variable. Okay. So C is equal to 1 initially.
It's too small, little bit.
Yeah. This is better. Wait. This is okay?
Yeah, okay, ma'am.
Okay. So first, temp. Okay. In temp, what we are storing? Self dot head. What is this? What is self dot head? Head node of what? The doubly linked list. Right. See, in init, self dot head is what? The pointer to the first node of the linked list. Right? In the question also it is given that we need 2 pointers, one to the first node, one to the last node. So self dot head contains reference to the first node of the doubly linked list. Self dot last is referring to the last node of the doubly linked list. So I am just storing that self dot head in temp. So temp is now also pointing to the first node of the doubly linked list. Okay. Next, while. So you tell me something. If I want to insert at position 5, till which node should I traverse?
Till 4.
Till 4.
Till 4.
Right. Then I have to change the pointers. So while C is less than, what should be the range? Pos minus 1.
Boss.
Okay. Pos minus 1. See, why you'll see. After this, so in every iteration what we are doing, temp will be equal to temp dot next, right? Until we reach the position that we want. And C also has to be incremented, so C plus equal to 1. Then you come out of the loop. I will explain this with an example. Let me write first. Then once this is done, see, when are you coming out of the loop? Let's say I want to insert at position 5. Fine. C is initially 1. Temp is pointing to first node. So C is 1. First iteration 1 is less than 4. Fine. Temp is equal to temp arrow next. Now temp is pointing to which node? Second node. Fine. C is 2. 2 is still less than 4. Temp is now again updated. Temp is now pointing to third node. C is now 3. 3 is again less than 4. Temp is again updated. Temp is pointing to fourth node. C is again updated. C is now 4. So 4 is not less than 4. But what is temp pointing to currently? Fourth node. Right? So at this point, I'll step out of the loop. Then outside the loop, should I tell this one more time, this loop part? This part?
Yes, ma'am. I just missed it, ma'am.
Look, if I want to insert at position 5, right? Then pos minus 1 is 4. C is starting at 1. So for first iteration of while loop, 1 less than 4. Correct? Then I come inside the loop, temp is updated. Temp was initially pointing to first node. Now it is pointing to which node?
Second.
Second node. C is updated to 2. 2 is less than 4. Next iteration, Yes. Temp is again updated. Temp is now pointing to third node. C is now
3.
3. Okay. Temp is again updated. Temp is pointing to fourth node.
Yes.
Now C is 4. So 4 is not less than 4. At this point, the loop will stop and I'll come out. So temp is currently, yeah.
We can also write C not equal to post minus 1.
No, then it will go for one more iteration, right? We have to stop at the previous one. That's why it's strictly less than. Just do a dry run, these things. See, loops, you cannot be confused. Loop, you have to have that idea clear. Okay. Data structure, loop is a very important thing. So if you are having doubt in loops, just do dry runs. That means the loop concept is not clear. So for every iteration, temp is just pointing to the next node. And this will stop when temp points to fourth node. If I want to insert at position 5. Okay. Then it will come out of the loop. Now temp 1 outside the loop. Temp 1 will store what? Another temporary variable I'm bringing. To store temp.next. What is temp.next? If I want to insert at position 5, temp is currently pointing to position 4. So temp.next is which? Fifth node. So temp1 is a temporary variable which is now pointing to the fifth node. Why I'm doing this? Because I don't want to lose this address, right? Because in the new node, that is now going to be the fifth node. But I don't want to lose that previous fifth node's address because that also I need for it to be the sixth node to make that link, right? So that I'm storing in temp1. Next, temp.next. Temp.next is what? Temp is pointing to fourth node. So temp.next is
fifth node.
Fifth node. In fifth node, I'm storing what?
The new node.
New node. So in the temp.next part, that means in the address part of the fourth node, I am now storing what? The new node, which now becomes the fifth node. So I also have to change the new node address, right? So new node address should point to which node?
Temp1.
Temp1. That is the previous fifth node, which is now the sixth node. So new node.next is equal to temp1. Fine. What else I have to change? The previous, this is a doubly linked list. So new node dot previous has to be updated too. What should be new node dot previous? Temp itself, fourth node.
Yes.
So new node dot previous is temp. What else am I missing?
Oh, temp1 dot previous is new node.
See. Temp1.
The sixth node has to point to the new fifth node. No?
So sixth node has to point to the new fifth node, right?
Yes.
So what is that sixth node?
Temp.
This is just temp.
Temp.
See. One thing understand. What is temp currently?
Initially it starts with fourth, ma'am.
Fourth.
Then we change it to.
Initially temp is pointing to fourth.
Yes, ma'am.
Then in temp1, I'm storing the fifth node address.
Correct, ma'am. Yes.
Then in the fifth node address part, that is the fourth node address part where fifth node was previously being stored, we now store the new node address.
Yes, ma'am.
Okay. In new node next, I'm storing fifth node address, which is now the sixth node.
Correct.
New node previous is now what?
The old one, the fourth one.
That is the temp,
yes,
which is
correct.
still storing that
fourth
address. So what link is now left? Temp1 dot previous. Right? For the sixth node also, I have to make that link.
Yeah, temp1 dot previous is equal to new node, I think. No?
Temp1 dot previous is equal to new node. Let me see all the links once. So fourth is now pointing to fifth. Fifth is pointing to sixth. Okay, both are updated. So temp.next and temp1.previous both are updated. Fine. Nothing else needs to be done, I think. Let's see. If anything is wrong, then we'll get that from the result. But this is the insert at the new position. So all the nodes are now linked, right? Fourth is pointing to new fifth is pointing to sixth is also previously pointing to fifth, and fifth is also previously pointing to fourth. So all the links are done. Next we have to traverse. So I have to write another definition to traverse the linked list. So there will be two definitions, one to traverse in the normal way, that is front to rear, and another for reverse. Okay. So traverse just takes self, that is the doubly linked list object. In temporary, just store what? If I want to go from first to last, which node I need? Head.
But have they asked for a traverse?
Mama,
Yeah,
It
see,
works. It
this
works
one is
like that only. It worked for me without the traverse.
no,
yes,
actually,
ma'am.
this one. See why I'm writing the traverse, because wait, why isn't it scrolling? Yeah, in the output you see there are two different traversals given, right? So
Yeah,
is
but
the traversal function there?
No,
The
mama. It's actually, I guess, hidden because it works for me without the traversal.
yeah, but they have not
okay,
asked for the
okay. I
output.
think this is
So
hidden. This is the hidden part
yeah.
of the prefix code. Okay, fine. Let's try test running then. Because see, I actually don't write in this portal, so I am not familiar. I write in Spider only. Okay, which is not running. Some link is off. I was feeling like it. Some link is off. I think there should be one more link here, which is temp.next new node.
That is already there, no man.
Yeah, line number 28, man.
Okay, that is done. So why isn't it? What is wrong? Expected output.
Ma'am,
Okay,
indentation.
indentation is wrong. Okay, this is one thing in Python.
While loop indenting.
This
Yeah, the
one,
whole
no.
no. The whole loop indentation is wrong. At DEF, you'll have to take a space. At the function definition where you define it, DEF on top. Yeah,
Okay, okay, this one.
yeah. Then
Then I
the
think it should be like this.
all of them need one spacing.
Mm-hmm.
Rest of the
Right. Yeah. Okay. So this is working. So that means that suffix code is hidden. Okay, that's why we can't see it. This is the visible part of the prefix. Okay. Anyways, you should know how to write those traversals. It's very simple. So this part of the code, anyone has any doubt? How to insert at a specific position? I mean, mainly the thing you have to do is this allocation, right? The correct address allocation. That's the main thing here. So wherever you are inserting at that position, so we will travel till the node before that. If I want to insert at n position, I'll travel till n minus 1th position, and then I will start changing the nodes addresses. That means n minus 1 node should now point to new node, right? New node should point to the previous nth node. Nth node, current nth node, right? Its previous should point to the n minus 1th node, and the previous nth node, which is now the n plus 1th node, that should point to the nth node, the previous. So both pointers you have to update. For the fourth node, for example, if I want to insert at position 5, then the fourth node next part has to be changed. Okay, and then the new node, both links you have to change, next and previous, because that is a new node. And for the previous fifth node, which now becomes the sixth node, for that only you have to change the previous part, because next is pointing to seventh node. That part is okay. Next part is fine. Okay. Any doubt here? Tell me. In the loop, are you anyone having any issue? Why the loop is?
Ma'am, can you write it once if possible?
Write it like you want a dry run.
Like, yes, the drawing part.
So I'll quickly just write. Let's say this is position 1 in which I have 10, then this is position 2 in which 20 was stored. Fine. And then there was another position, let's say 3 in which 30 was stored. Now I want to insert a new node which contains 15. But this is position 1, position 2, position 3. I want to insert this 15 at position 2. That means this position, right? So how the linking will happen? currently this is pointing to this is pointing to this. So to break this link, first I have to make sure that this 10 is now pointing to this node, right? Okay, let me add one more because this is doubly. So 2 links are there. See, the next of this is pointing to this, the previous is pointing to this, next is pointing to this, previous of 30 is pointing to this, and next of 30 again can be none if this is the last one. Is the point just till now, is it clear? Just this actual list. This is the doubly linked list. Every node has 2 pointers, one previous, one next.
Ma'am, what about the 15th one?
15, yeah, I'll come to it. But the actual doubly linked list is clear?
Yes, yes.
So now I want 15 to be in the place of 20, right? Position 2. So 20 has to move one position to the right. That means 20 will now become at position 3, 30 will now become at position 4. Okay. Now the linking will happen how? The next part, this is the next part of the first node, that will now point to the new node. Okay. So this link is broken. 10 to 20 link is broken. 10 is now pointing to 15. 15 will point to what? Which node? 15's next part
20.
should point to 20. So 15 is pointing to 20. 20's previous should now not point to 10 anymore. It should point to
15.
15. So this linking is only what we are doing. So now this becomes position 2, this becomes 3, this becomes 4.
Okay. Got it.
Okay. Yeah. Any other doubts or next question we should do? Okay, let's do number 3, right?
Ma'am, you are not submitting.
I am not submitting, it's fine. Test cases are running, you can submit. Okay. Better if you do with me and then you can submit also. Okay, this is the third one. See, this is the last one with linked list. Okay. So this is asking what? Same thing. Again, this is a singly linked list, not doubly. So only one link which is pointing to the next. Okay, head is a variable that contains reference to the first node of the linked list. Now, you are given to, okay, the person, I don't know what's your name, who was asking the type of that dot next, that object.
Sandeep, ma'am.
Yeah. So Sandeep, see, here it is saying, suppose it has a head variable that contains the reference to the first node of the linked list, right? So head is what? Is head a node? Head is just a reference, right? The first node is different. So head is containing reference to the first node, but you can see in the code, we are having in that code, you can see in line 23, it is given that head is equal to node, right? So we are creating the node and that reference is being stored in head. So obviously if we see the type of head, it will be of object type node. Class type will be node. Okay. But we are calling it as a reference. So you can relate to it like that. That next part is storing another object. Okay, but we are referring to it as a reference variable.
Understood.
Now you are given two non-empty linked lists n and with n and m nodes. So first empty linked list has n nodes, second one has m nodes. Both of these are sorted in ascending order. Okay, so the linked lists themselves are sorted. Your task is to merge these two sorted linked lists into one sorted linked list. Okay, so they are inherently sorted, both linked lists L1 and L2. You have to merge them in a sorted order. That's it. So we have to write a function called merge sorted list, which takes 2 pointers. Head 1 is the head pointer of linked list 1. Head 2 is the head pointer of linked list 2. So head 1 and head 2 are references to the first nodes of two sorted linked lists. The function should return the reference of the first node of the merged sorted linked list. I mean, once you have merged these two linked lists L1 and L2 into a sorted linked list, then the function should return the reference to the head of that, right? That means reference to the first node of that sorted list. That should be returned. For example, if these are the two lists, first list is having 1, 3, 5, 7, 9, 11. Second list is having 2, 4, 6. So the merge list will be 1, 2, 3, 4, 5, 6, 7, 9, 11. Right? But it should do what? This function, this merge sorted list should just return the head pointer. Okay, then we'll have that display and everything, and we can just traverse through it and print it.
Ma'am,
Yeah.
in this question, do we mess with the original list or we make a entirely new
We'll make
list?
a new list. Yeah. New list will
Okay.
use. I mean, new list, so we'll have a new head basically. Okay.
Yeah.
That's it. And then all the same things are reused from two lists. You're not creating new nodes. That's what I'm saying. Just a new head you're creating.
Oh, we will reuse the
Yeah,
existing
yeah. This
nodes.
existing node only. We'll just shift the pointers. That's it.
Okay.
Okay, so here is any of the code given? Nothing is given, but I think all of it is hidden. I mean, I don't need to write it, I think. I just need to write this function, right? Write a function merge sorted list. I think all the rest of the code is there. So merge sorted list. So what is the idea you tell me? Basically the merge sort that we did last day. That same thing, right? So you have two sorted lists, now you're merging them together into another sorted list. So we did merge sort last day, that same concept. So it is taking head 1 and head 2. How do we proceed? Any idea?
We need two pointers, temp1 to point to the head1 and temp2 to point to head2.
Right.
Then we will
We'll
start.
also need a new head, right?
Ma'am?
We'll also need a new head, let's call it head 3, which will point to the first node of the sorted list.
Yeah, yes, ma'am.
Okay.
Then we'll start comparing temp1.data and temp2.data.
Right. So after that, then according to the comparison, we'll shift the pointers. Whichever
Yes.
one is smaller should come first. Okay, let's start writing. So temp1 is storing head 1.
No, but why you need head 3? I didn't understand that.
Because see, head 1, I'm not messing with it. Okay. Head 1 is pointing to the first first node of the first linked list. Now you need head 3. Why? Head 3 will be pointing to the first node of the sorted list and that should be returned. Okay.
Okay.
See, if I have just head 1 and I return head 1, then that will just traverse to the first linked list, not the new sorted linked list.
No, but are we creating a new list? Is that what
No,
you're
no, we are
saying?
not creating.
Right,
We are
right,
just
you're just
shifting
shifting
pointers.
pointers. Yeah, yeah, I thought so.
Okay. I'll explain. Let me just write. It will become clear. Temp2 is storing head 2. Okay. Let me have another one, head 3. This is the one that I have to return in order to display. So none. It is initially none. And we'll also have one more variable, temp3. Why we need that, we'll see. Okay. Now the while loop will run till when? When one of the lists gets exhausted, right? So how long will the list run? When both temp1 and temp2 are not none, right? That
Yes.
means they're not the last node. So while temp1 is not none and oh wait, I need to increase the font for this. You can see,
Ma'am,
right?
you can directly write the temp1 and temp2. It will automatically take none.
Yeah, it will take none. I can write that also. Is not none. Let's just write. Then what is this? Is the condition. So until one of them becomes none, this loop will run. Right. Then I will start comparing. So now here there will be if else statements, right? So if first condition is what, temp1 dot data is less than temp2 dot data. So for first iteration, which two data is it comparing? Let's take this, for example, the sample input given left hand side C. So the first of the first list, that is 1, that is in temp1 dot data, right? And the second list 2, that is in temp2 dot data. So this 1 and 2 is being compared. Just take this sample input. So is this true in this case? 1 is less than 2?
Yes.
Yes. So what we have to do? See.
Increment.
I'll just first take one more variable, which is, let's say, selected node, in which I'm going to store temp1. Okay.
Yeah, you can then have temp1 pointing to that temp2.
Temp1 dot next.
Yeah.
Right. That is one. This temp1 has now moved. Okay. To the next element, because one element has been added from this first list. So temp1 pointer will move. Temp2 will not move. So temp1.
Do we have to give less than or equal to? Because if there are if elements are
No,
similar.
no. We are already thinking that these are all sorted in ascending order, so there are no duplicates. Okay.
But look at the test
It-
cases.
Yeah, look at in the test cases also you can see. Wait. That is not required, I think.
The third test case, there is like both the elements are similar.
Yeah,
One,
if
two.
this one is like that, right?
Yeah.
So in that case, I will write an else part also. Okay, that else part will take care of it.
Okay.
So then temp1 I can change to temp1 dot next. Now if it is not less, then it can be equal or greater, right? In that case, else part will contain what? Selected node equals to temp2. Okay, if equal, then also I can take temp2. If greater, then I have to take temp2. And temp2 will be set to temp2 dot next. This is one part. Okay. Now this is now what if head 3 is none. Okay. If head 3 is none, then what happens? Head 3 is initially none, right? After that, you have to check that. If head 3 is none, let me put another gap. Yeah. So initially head 3 is none, we have set it to none. That means the new node doesn't have anything in it right now. That's why head 3 is none. It is not pointing to anything. Right? The new list that we're trying to create. So now currently the head 3 is not pointing to anything, so head 3 is none. Then head 3 will point to what? Which node should head 3 point to? Selected node. Selected node only is containing the smallest one, right?
Yes.
Or in case of duplicate, the duplicate one, whatever it is. So head 3 should point to selected node. This is the first node. Okay. Else, that means now if you are not at the first node, if first node is already there, you are trying to insert the next node. Or this is not actually inserting, this is basically I'm just doing pointers here. Right. So temp3. First of all, here you have to do one more line that temp3 should be having the head 3 address, because we are not going to mess with head 3 anymore. Head 3 will remain that first node address. But if head 3 is not none, that means there is already some value in head 3, right? Head 3 is pointing to selected node. Then else part will contain temp3 dot next. Temp3 dot next is basically what? Head 3 dot next, right? If one element has been inserted, again come back to the example. 1 and 2 were compared, right? 1 was the smaller one, so 1 was inserted in selected node, right? That address is now in selected node. Selected node is containing temp1. This assignment line 9, and then temp1 moved on to the next. Then I came to the next if statement. I checked that is head 3 none. Yes, this was the first iteration, so head 3 is now pointing to selected node. Okay, and temp3 is storing head 3. So basically temp3 is also pointing to selected node. Now for the second comparison. Okay, for the second comparison again, now what is temp1? Temp1 was moved one position, so temp1 is now which data? In first linked list 3. This sample input on the side, see, temp1 moved one position, right? So temp1 is now 3, temp2 is still 2, correct?
Yes, ma'am.
So is this condition holding? Line 8, temp1 data is less than temp2 data?
No.
No. So you come to the else part. Selected node is now containing what? Temp2, right? Selected node is now containing temp2.
Yes.
and temp2 pointer is now moving to the next one. So basically in the list it is now pointing to 4. Okay. Now you come to the next if statement. Is head 3 none? No.
No.
First node was inserted. So head 3 is pointing to the first node. Right. So you will come to the else part now. So in else part, temp3.next. So temp3.next is what? Basically head3.next only. That is the next part of the first node.
None.
Okay.
The selected node.
Selected node. So temp3.next is going to contain the new selected node in which I have stored the new next data. So this selected node is what will keep changing the value. So temp3.next is now pointing to the new selected node, and temp3 will also have to change its pointer to temp3.next.
Next.
Okay. Now this loop will continue until one of the lists exhausts. Right. So
Excuse me, ma'am.
Yeah.
Ma'am, in the else block, temp3.next equals selected node means that temp3 points to the selected node.
temp3.next, okay, is pointing to the selected node currently, and then temp3, this
Ma'am, I think the
pointer.
dot next we have to remove, na? Temp3 becomes the selected node.
Which one? No, temp3.next. See, temp3 initially was pointing to head, right? First node. Then selected node value changed in the second iteration. So now that temp3.next has to point to the new selected node. That's why temp3.next is equal to new selected node. The selected node value has changed. In first iteration, selected node was storing 1.
Understood.
Right, temp. That thing, that change is happening here. Then I also have to change the pointer of that temp3 to temp3.next. That is the new selected node next part. Okay, so that I can go again for the next node like that. So this entire loop will run until until list 1 or list 2 exhausts any one of them. So what happens to the rest of the elements in the other list? So I also have to give a pointer to that okay, here the comparison ends, then there are, let's say, more elements left in list 1. So the element which is currently left in list 1 first, right? I'll point to that element, then that element can point to the other elements which are left. Anyways, these are all sorted, right? So I don't have to worry about that sorting. I just have to point to that element which is left. So let's say there are, I stepped out of the while loop. In list 1, there are 4 elements left. Okay. So I'll point to the first element, and then that first element will point to the rest of the elements. So I just have to establish that link. I have to attach the rest of whichever list is not empty. So if temp1 is not none, then temp3.next should be what? Current temp1. Similarly, if temp2 is not none, then again temp3 should point to temp3.next should point to temp2. And at the end, after all of this is done, what I have to return?
Head
3.
Head 3, sorry.
Okay. Then there will be some display function which will display the list. So let's test run once. Okay. What merge sort list? Again, I think some indentation error. Yeah. Okay. I have to write it from this.
Keyword def is missing.
Okay. Def. Yeah. Okay. Now tell me which is this pointer allocation clear for everyone? Which part did you not understand? This while loop, do I need to explain again for anyone?
Ma'am, please explain that else last else block in the while loop that then 3 dot next upward was elected or presents again.
This, right?
Yes, ma'am. Yes.
So let's think of the first two iterations. Okay. First iteration, head was none, correct? Then in the selected, head 3 was none, first iteration. Because head 3 was not pointing to anything. So in the first iteration, what happened? I compared 1 and 2 from list 1, list 2. 1 was the smaller one. So in selected node, I stored the address of that temp1 containing this 1 data, right? And then I increase the pointer to the next. Temp1 is equal to temp1 dot next. Then I checked, is head 3 none? Yes, in the first iteration it was none. So head 3 is now pointing to the current selected node, which is the first node for our entire sorted merge list. Okay, and temp3 is storing the pointer head3. So basically temp3 is also pointing to the selected node. Now in the next iteration when you go, which two numbers are you comparing? 3 from the first list, 2 from the second list, right? Second list pointer didn't move, correct? Up to this. So 3 and 2 when you compare, which data is smaller? Temp2 dot data is smaller. So you'll come to the else part here, line 12. And the selected node will now be updated to contain temp2, which is the node containing this 2 data in the second linked list. Data part contains 2, right? So current selected node is now containing temp2. And now I will increment the pointer of the second linked list. So now temp2 is pointing to the next, that is 4. This one. Okay. Now you again check, is head 3 none? No, head 3 is now pointing to the previous selected node only, right? It is pointing to the first node. So head 3 is not none. So you come to the else part. So since head 3 is not none, so temp3 was what? Temp3 was containing head 3. That means temp3 was also pointing to the first node only, that previous selected node, right? But now there is a second node. That is the selected node has been updated. So temp3 dot next, basically the next part of the first node is now pointing to what? The new selected node, which is containing 2, right? So temp3 dot next is equal to selected node. This selected node is the new one, which contains 2. And again temp3 pointer you now update to point to temp3 dot next. There is a new node link part. Understood? Should I write it?
No, ma'am, understood. Clear, clear.
Okay. Any other doubt, anyone? The linked list, if you're doing for the first time, it will take some time. Okay, so you try dry running more of these problems.
Ma'am, always after the first element, temp3 only is getting updated with the new selected nodes, right?
Yes, head
But,
will remain like that only.
that will remain like that. But
Yes, tell
our
me.
comparison is with temp1 and temp2.
Temp1 and temp2, yes. But that is just being used for comparing. Temp3 is the one that is actually the pointer for the whole merge sort list, the new list. Okay, it is not a new list. We are just working with pointers. We are not adding new nodes, right? But to traverse that, we will just use temp, because some pointer has to point to the last node always of that list.
Understood.
Because
So one
when
and
we
two are
come out of the loop, then that temp3 next will only store the pointer of the list which still has elements left in it. Yeah.
understood.
Last question. This is now on stack queue. Okay.
Ma'am, can you just move to the previous question? Just one.
Yeah. Is the code gone? Because I didn't know it is there.
Okay, ma'am. I just wanted to take the screenshot. Thank you.
Yeah, I'll share all this code on Discord. So last week also I'll share it. Okay. Now this is a very important question for all kinds of interviews. Also, there are many interviews ask you to write this in the coding round, that implement a stack using 2 queues. It's very popular. So we are going to implement a stack using queues. That's the thing. Okay. 2 queues will have, and using that we will do all the enqueue, dequeue operations, push, pop, everything. Okay. So what are the basic operations of stack? Push, pop, top is empty. Right. Push means you want to insert some element in a stack. So in stack, the uh, method that we follow is LIFO, so last in first out. Whatever is being entered last in the stack will be popped out first. If you want to delete, you have to delete from the latest element, right? Like a stack of dishes, you have to always take the dish that is on the top. So pop is what? Pop means deletion. That is delete from the top. Top is what? Top will return the top element. That is the latest element that has been added to the stack. And isEmpty is a function that returns Boolean value true or false. If the stack is empty, it will return true. If not, it will return false. So all these different methods we have to create, okay, for a given class called stack using queues. So what will be the input and output style? So for sample input, this. So these are all the elements that I want in my stack: 10, 20, 30, 40, 50. Next line of input will be 2. That is, if you want to pop 2 elements. If I want to pop 3 elements, I'll put 3. Okay. What will be the output? First popped element, second popped element. So in this stack, what is the last element that was inserted? 50. So that will be popped first. Then the next element is 40. That will be popped second. After these two are deleted from the stack, what is the top of the stack? 30. So that will come in the third line of output. And lastly, it is the isEmpty. So you will check, is stack empty? No, stack still contains 10, 20, 30. So it will return false. Okay. Problem statement clear? Okay, then I'll start writing.
Yes, ma'am.
So what is given to us? Class Q is given to us. Okay. These are some of the functions. So these things, if you have any doubt, you can ask me about any of these functions. So basically, see, here the enqueue is doing what? Usually in queue, what we do? We insert where? At the end, right? At the rear of the queue. And we delete from the first beginning, front of the queue. Okay, but here there is a little twist. See, every time you issue the enqueue operation, it will insert at 0th index, that is first index. Okay, and every time you do dequeue, it will pop from the rear, because pop method defined in Python, it will if you don't give an index as a parameter, no, then it will by default pop the last element of the list. Okay, so these are all given to you. You just have to write these 4.
Ma'am, can you again tell the what output we are trying to get?
Yeah, see, if input will be what? The elements that you want to push in your stack one by one, right? 10, 20, 30, 40, 50. These are the elements.
Yes.
Okay, and next line of input is the number of elements that you want to pop. So 2. That means first 2 elements will be popped. The top element and then the next element.
So why we are also showing the
So
30?
these, these will be default. Okay. So for any sample input like this will be the output. I mean, first pop 2 elements will be shown, and then the top and isEmpty will be shown by default. Okay, that will be returned. So we will write those return statements in those function definitions. Those will be returned whether you ask for it or not.
Okay, so if there is more than 2 elements, then one element will be extra always.
No, it's not extra. See, there are 5 elements in the stack, right?
Yes.
I want to pop 2 elements. So which are popped? The elements that are inserted last, 50 and 40. These two are the last 2 inserted elements. So first 50 will be popped, then 40 will be popped. After this, stack contains what elements? 10, 20, 30. So what is the top element? 30. So
30.
that will be returned. Then you will ask, is the stack empty? No, it has elements. So it will return false. So basically this top element and isEmpty, you are not asking in some input way. So it is default returning. Okay.
So if we pop 3 elements, then 20 will also show.
Yeah. 20 will also show. And then also this isEmpty will come as false.
Okay, got it.
So let's write. So queue is defined, stack class is defined. We have to write all these methods as a part of this stack class, right? So first we will write, let's write init is given. Let's write isEmpty first. So
Empty is best here.
Yeah. So def isEmpty. This is just a 2-line. Okay. We will take self as the argument. So what you have to check, since there is something called size that stores the size of the stack, right? So if it is empty, then size will be 0. So just in the return statement, you return, tell me what is the logic, self dot
Dot
size
size
is equal
equal
to
to
0. Then this is empty. Next we will do top. Let's do top. So def top, again take self. So for this, what we have to do, we have to first check that it is not empty, right? So if not self dot is empty. So if it is not empty, then return self dot q1 dot items. Which index should I return?
0th.
Is 0th index having the latest element after all the elements have been inserted?
Last.
Last. So I can do -1, last element.
Yes.
Okay. Else, what will I do if it is empty? For that also you have to write an else. Just write print stack or just write return stack is empty. Okay. Next we'll write push. Okay. See here why these are all given.
Ma'am,
Yeah.
aren't we giving means pushing the elements from the 0th position? Like,
No. See here. Let me just draw it quickly. Then you will understand better. Yeah. What happens? We have two queues. Okay. We have q1 which is initially empty and q2 which is also initially empty. Now you can see in the default functions that are given, enqueue is doing what? It is appending at 0th position, 0th index, right? Appending the key at 0th index. Dequeue is doing what? It is deleting or popping from the last index. Okay. Now let's say in my stack I want to enter these three, 1, 2, 3 in this order. So for first insert, this is the algorithm. Okay. First we will insert in q2. Insert in q2. Okay. So 1 is inserted. What index is this? 0th index. q1 is still empty. Now I will check, is q1 empty? Yes. If q1 is empty, then I will just do a swapping. Okay. What is my goal? I want the entire stack to be maintained in q1. q2 is only used when I am inserting a new element. Okay. So how I can do that? Since q1 is empty in the first iteration, I can directly swap. So in q1, just store whatever is there in q2, and q2 will be reinitialized to a new stack. So use another q variable, let's say call it self.q, okay, which is a empty. So then you swap whatever is present in q1. Okay, q1 will basically contain q2, and q2 will become empty. I'll explain this when I write the push function. Okay. Then in second insert, what happens? q2 is now again empty, so it is ready to insert new element. So you enter 2. 1 is inserted. 2. q1 contains what? 1. Is q1 empty? No. So what you will do? You will take whatever is present in q1, you will use the dequeue operation. So you will pop it from q1 and you will insert it in q2 first. Okay. Since q1 is not empty, that's the condition we are checking. Then the operation is that in q2 you will enqueue whatever you are dequeuing from q1. Basically you will empty q1 and put all the elements in q2. Okay. So how will q2 look like? If I dequeue, this one will come out. Where will it be inserted in q2? Before 2 or after 2?
After 2.
before 2, because NQ operation inserts where? At the 0th index. So this was at the 0th index. Now 1 will be at the 0th index, 2 will be at the 1th index. It will be like 1, 2. Okay. Is this part understood? Why it came before 1, why it came before 2?
Okay, so now, ma'am, when we are again going to push into Q1, then we'll just pop
Yeah,
and
now we are going to just swap. Okay. Just Q2 will be stored in Q1 directly. So Q1 will now contain 1, 2, and Q2 will again be reinitialized to an empty queue. Now when you do the third insert, Q2 will contain now 3. You are inserting 3 at 0th index. Q1 at this stage contains 1, 2. Index 0, index 1. Q1 is not empty. So again, what I have to do, that same NQ DQ. So take everything from Q1, DQ it, and insert it into Q2. So final Q2 after the transfer will look like what? 1, 2, 3. First this 2 will DQ and then insert here in 0th index. Then 1 will DQ, insert in 0th index. 2 will become 1th index. 3 will become 2nd index. So Q2 will contain this. Then again you do the swapping. So that Q1 now contains everything that Q2 was containing, 1, 2, 3, and Q2 is again restored to be a empty stack. So Q1, okay. Now if I say that pop the first 2 elements. So which elements will be popped? Tell me. In
3 and
Q1.
2. 3 and
First
2.
3 will be popped, then 2 will be popped. So the latest element that I insert in the stack will be at the last index of the list. Okay. This is your top of the stack. So that's the algorithm. Now how I can implement this?
Excuse me, ma'am. Ma'am,
Yeah.
in this, when you were talking about the third insert, and you said that Q1 will first element will DQ and it will go into the 0th index. Can you please repeat that part just once again?
Look, Q2 has 3, right? And Q1 has 1 and 2.
Yes,
This is
ma'am.
clear? Now
Yes, yes.
I need to DQ from Q1. So if I DQ from Q1, which element will be popped first? 2?
Yes, ma'am. Two. Yes,
2
ma'am.
will be popped and 2 will be NQ'd in Q2. NQ does what? Inserts element in 0th index. So then
Okay,
Q2
okay.
will be changed to 2, 3.
2, 3.
Now Q1 still has 1 element, so again do
Yes,
one more
ma'am.
DQ, that is popped.
Okay.
Again
Yes.
inserted in 0th index, 1, 2, 3. So latest index
Understood.
is at the last element. Okay.
Okay. That is the top. Okay.
Yeah, that is the top. Then when you pop this or DQ this, whatever, then this becomes the top. Whatever is
Thank
at the
you.
last index. So now this simple thing we are going to implement here. Okay, definition of push. So push will take what as parameters? Self and the data that I want to push, right? So first we will maintain a size. Okay. So self dot size will be increased when I want to push. So I can write plus equal to 1 here. Then first we will enqueue the new data item in Q2 as per the algorithm. Q2 is empty, first put it inside Q2. So self dot Q2 dot enqueue. What am I enqueuing? The data. Okay, now Q2 has the new data. Next I have to check, is Q1 empty? So while self dot Q1 dot items is the list, okay, that is corresponding to Q1, that Q is not equal to empty. That is, as long as there are elements in it, this loop will run. What will I do? I'll enqueue everything from Q1 and I'll dequeue everything from Q1 and enqueue it to Q2. Basically transfer all the data from Q1 to Q2. So self dot Q2 dot enqueue, in the bracket, what are we enqueuing? Whatever we dequeue from Q1. So self dot Q1 dot dequeue. Okay. This loop will help transfer everything from Q1 to Q2. At this point, Q1 has nothing. Q2 has everything, right? And the last element is the latest element that has been inserted. Next, I'll do the swapping because I want to maintain everything in Q1, and Q2 I'll only use when I need to insert a new element. I'll maintain the stack in my Q1. So I have one more variable called self.q. Okay, I can directly assign in this. This is a Q object. Okay, I can assign in this self.q1. So Q1 is empty. So basically Q is now an empty list, right? Then in self.q1, I'm going to store everything that I have in Q2. I'm doing the swapping here. So Q is just this self.q is just a swap variable that I need. 3 variable swapping, same thing. So self.q2. Next, everything from Q2 has been transferred to Q1. Now Q2 has to be reinitialized to empty Q. So self.q2 will now be assigned self.q, which is empty. This is push operation. Is it clear for everyone? Whatever we saw there in the dry run, that same thing we have implemented, right? Any question?
Ma'am, but self means the present object. Now,
Yeah.
present
So we will
object.
call this, right? Here we will call. See, for every element in your input, you will call the push function.
No, no. What I'm saying is our class Q has only one list defined, like items. So will there be not confusion between Q1 and Q2?
These are different objects, no? Q, Q1, Q2 are different objects of that class. So they all have their separate lists.
Like I'm not seeing where Q1 is getting created first time. Let's say in the code, ma'am.
Q1 is getting created.
In the stack, you are creating. Okay.
Yeah,
Okay.
yeah, in the stack.
In the stack.
Okay, this self.q1, self.q2, see the Q is assigned, right? So that is where you create both the Qs.
Understood.
Okay.
So, ma'am, object two objects created means
Yes,
they are
Q1,
separate.
Q2 are two objects, separate objects having separate lists.
Okay. If we write Q1 is equal to Q2 also, Q1 will be created like it will be a new copy of Q2, not the Q2 itself.
No, it is just, see, when I'm assigning Q2 to Q1, it is just storing whatever is there in Q2 in Q1. It is nothing new. That same Q1, it is now just storing the Q2 elements.
But let's say I do Q1 plus 2, then will that plus 2 happens for Q2 also?
No, just for that.
So physically there are two different copies.
Two
Q1
different,
and
yes, absolutely different.
Ma'am, in the last line, it should be self.q2 is equal to empty.
Sorry. Yeah, this will be self.q. See, Q is already empty, right? Because after dequeuing Q1 became empty. Then I assigned Q1 to Q. So Q is basically empty. So that empty Q is being assigned to Q2 lastly. Okay, that's your.
Ma'am, can you repeat that self.size plus 1?
Yeah, this is just maintaining the size of the queue. Okay, that means how many elements are there in your queue. Okay, there is nothing else. This is just that so that you know the size. If you want to check is empty, then you need the size, right? So that's why if this is one element, then it is incremented one time, like that. So size is maintained for that is empty checking.
We are checking if there is one element in there.
See, in is empty, what are you checking? Self.size is equal to 0 or not?
0.
So this size you have to maintain, right? How many elements are there in a stack. So every time you push an element, you increment size by 1.
Okay.
Yeah. So last method is pop. So pop again takes self. Pop is easy. So what we have to do? We have to again check that it is not empty, right? If it is not empty, then we can decrement the size by 1 since we are popping one element. So firstly decrement the size and then do a dequeue. So if not self dot is empty, then first decrement the size of the queue since you are popping one element. So minus equal to 1. How do I go back? This thing I haven't used. I accidentally pressed backspace. Can I delete this thing?
Maybe Control Z.
That is not working. I tried. Okay, no problem. Let me just copy this to Spider. That's why I don't use this. This looks very difficult to me. I think I already have this written in Spider. Let me check once. Yeah, I have this. Okay. So this is your pop, basically. This one. This is pop. So if not self dot is empty, then you decrement size by 1 and return self dot q1 dot dq. That means dq the q1 queue, which is actually maintaining the original stack. So when you do dq, what it will do, it will pop the last element, right, which is the current active element, the latest element that you entered. So that is pop. Else, if it is not is empty, is giving, I mean, it is empty. That means it is giving true. So else part will just return stack is empty. Okay. See, when I write, I write all the functions. That's why it gets easier to understand. That's why. Okay, let's try running it. So I have to give a stack as an input, right? What test cases are they using? So let's do this 10, 20, 30, 40, 50 and 2. 10, 20, 30, 40, 50. And then 2 elements I want to pop. Okay, some extra print statement I had accidentally given. Let's delete this. Okay. Which two elements should be popped? 50 and 40. So 50 and 40 are popped, then 30 is the top and false because it is still not empty. Okay. Is this clear? All the functions, all 4 functions?
Basically,
yeah.
What we are doing is we're implementing stack using queue,
Two
queue
queues,
using
yes.
and queue using simple lists.
Simple
right?
list, exactly.
But list functions we are not using. We
Yeah,
are,
list functions we are using. So this dot pop is a list function only. Insert is a list function. Okay, in NQDQ, these things that we have used, these are all inherent list functions.
Inherent list function. Okay.
Yeah. Again, we are using list slicing here. So it is all list. Stack queue, both are implemented using list only. Just the stack operations are done using a queue. 2 queues. Okay, why 2 queue? 1 queue is used to enter new element. Another queue keeps track of the original stack. Okay, all 4 are clear? Any doubt, anyone? Alright, then I'll give you these codes for these 4 problems. That's it. Okay, if you don't have any more doubts, then we can close. Thanks for joining. We'll meet after paradox.
Ma'am?
Yeah.
If we have like 2 elements and we create this, then what will be the answer? Like pop 2.
Then both elements will be popped and is empty will return true and top will not have anything, so it will return stack is empty.
Okay. Ma'am, can you show the merge code also in Spider?
Yeah, I have it. In this. Yeah.
Ma'am, can you like draw this once, because I'm a bit confused with the concept.
Okay. The basic thing is same as merge sort as we did in last week. Okay. So we have 2 lists. This is 2 linked lists. This is the first linked list. Let's say it contains 1, 3, 5, 7, 9. Second linked list, it contains 2, 4, 6, 8. Okay, these are sorted. Now I want to create another linked list, which is the merged result of these 2 linked lists, also sorted in ascending order. Right. So what is the merge sort comparison that we learned last week? This first 2 elements, first I'll compare. Whichever is the smaller one will become the first element of new list. So head 3 will point to 1, this one. Then this pointer is moved to the next, right? Next comparison will be between 2 and 3. So which is smaller? 2. This will become the second. So now 1 will point to 2. Again, since this one is now a node, proper node of the merge list, so again this pointer will extend to the next. Okay, now 4. Okay, I will not draw this arrow. So now currently we are comparing 3 and 4. Which is smaller? 3. So 2 will point to 3. Again the pointer will increment to 5. From whichever list we are finding the smaller element, that list's pointer will move on to the next element. Okay. Then you do the 4, 5 comparison, then 4 is inserted, so 3 will point to 4, 4 will point to 5, 5 will point to 6, like this it will go. And then you just display the merged list. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay. Yes. Ma'am, in the queue problem, if we don't have the number of elements we have to pop, so will it give index?
Yeah, I mean that is what this is working on, right? See, this is the prefix code, I think, given here. See, when you are calling here, push, you are calling, right? Then there is this print a or top. So this, if you don't want to know what is the top, you just remove this.
No, like we have 10 and 20 and we pop 3 elements. Then
No,
what
then it is invalid, right? See, before popping, we are checking that is it empty or not. So if it is empty, then it will just return stack is empty.
But there is 2 elements, right?
2 elements, so you pop the first element, then the second element. Then when you come to pop the third element, then the stack is empty at that point.
Okay, so for each element, it is iterating.
Yeah, it is calling the pop function.
Okay, got it.
Okay. So then you return this stack is empty.
Thank you, ma'am.
Yeah. All right. Yeah. Thanks, everyone. Have a good night.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, just 1 second.
Yeah.
Good session today, ma'am. Thanks for the session today. And just one more point. I think something is being done for OPP eligibility.
Yeah. We are discussing that. So there will be. We are still discussing that, but there will be some announcement regarding it. Okay.
Yeah. No, really, thank you for that, ma'am. Because removing eligibility itself, was.
Yeah. It was a bit harsh. We discussed it.
So, thank you to the instructors for that, considering this thing.
No issue.
As a working professional, it's a boon to us. Otherwise, I would have missed the whole 20%.
Yes, that's why we are reconsidering it. We'll give everyone an announcement.
Right. Thank you.